Have you ever wondered just how powerful the sun really is? This colossal star sitting at the heart of our solar system is so much more than just a bright light in the sky. Its size alone is mind-boggling. Over 1 million Earths could fit inside it. And even though it's about 93 million miles away from us, its influence reaches far beyond its own fiery surface. Composed mostly of hydrogen and helium, the sun is a fusion powerhouse, creating light and heat that sustain life on our planet. Every ray of sunlight that warms your face, every plant that grows towards the light, owes its existence to the sun's energy. Imagine a world without sunlight, cold, lifeless, and utterly devoid of the life we know and cherish. So that's our sun, a truly massive and powerful star, without which life as we know it wouldn't exist. But how does the sun, a giant ball of gas, generate so much energy, you might ask? Well, let's dive into the fascinating world of nuclear fusion, the process that powers our sun. Nuclear fusion happens when two atomic nuclei combine to form a heavier nucleus. This process releases a tremendous amount of energy. In the sun's core, hydrogen atoms fuse together to create helium in a process known as the proton-proton chain. This reaction is so powerful that it releases photon particles, which are essentially packets of radiant energy. Imagine this. Every second, the sun converts 4 million tons of matter into energy. That's like 1 billion nuclear bombs going off at once, every second. Now that's a lot of energy. But how does this energy reach Earth, you ask? These photon particles, born in the sun's core, embark on a million-year journey to the sun's surface. Once they escape the sun, they dash across the 93 million miles separating us from the sun in just over 8 minutes. We call this light, but it's also the heat we feel on a sunny day. This energy is vital to life as we know it. It drives photosynthesis, the process by which plants convert sunlight into chemical energy. This process not only sustains plant life, but it also produces the oxygen we breathe. So it's not an exaggeration to say that we owe every breath we take to the sun. In addition to that, the sun's energy also regulates our climate. It heats the Earth's surface, creating wind and driving the water cycle. This energy balance is what makes our planet habitable, allowing for a vast diversity of life. The sun's energy, then, is what keeps our planet alive and functioning. It's quite incredible, isn't it? So the next time you feel the warmth of the sun on your skin, remember that you're feeling the result of a million-year journey from the core of the sun, a journey that sustains life on our planet. Quite an amazing thought, don't you think? Just like every other star, our sun has a lifespan, but how long is it? Now, let's delve into the captivating story of our sun's lifespan. Our sun began its life around 4.6 billion years ago, a mere cosmic infant in the grand scheme of the universe. It formed from a vast cloud of gas and dust, swirling and condensing until the heart of this cloud ignited, giving birth to our star. The sun, like all stars, is a massive nuclear fusion reactor. At its core, hydrogen atoms are constantly colliding and fusing to form helium, releasing a tremendous amount of energy in the process. This stage of a star's life, known as the main sequence, is where our sun currently resides. But what happens when the sun exhausts its hydrogen supply? Well, as the hydrogen at its core depletes, the core begins to contract under the force of gravity. This contraction generates heat, causing the outer layers of the sun to expand. Our sun will then become a red giant, its outer layers extending possibly as far as Earth. But don't worry, this transformation won't happen for another 5 billion years or so. Following the red giant phase, the sun will cast off its outer layers and leave behind a hot core, a white dwarf. Over billions of years, this white dwarf will cool and fade into a black dwarf. So, if you're keeping track from the time it was born until the time it fades into a black dwarf, our sun's total lifespan will be about 10 billion years. Given that it's about 4.6 billion years old now, our sun is just about middle-aged in star terms. It's fascinating to think that our sun is just halfway through its life with billions of years left to shine. The reality of our sun's lifespan reminds us of the immense scale of cosmic time and the transitory nature of our existence within it. The sun doesn't just provide light and heat, it also has a significant impact on our planet in other ways. Let's delve deeper into these effects. The sun's rays are the driving force behind our weather and climate. It's the differential heating of Earth's surface that creates winds, ultimately shaping our weather patterns and climate zones. Moving towards the poles, we encounter a breathtaking spectacle. The northern and southern lights, or auroras. These stunning displays of light are caused by solar particles colliding with the Earth's magnetic field. But the sun's influence isn't always benign. Solar flares, Sudden eruptions of energy on the sun's surface can disrupt our technology. These flares can release electromagnetic radiation strong enough to interfere with power grids, satellites, and electronic devices. So, while the sun is indeed our life giver, it also has the power to disrupt our modern way of life. So, what have we learned about our sun today? Well, we've discovered that the sun is not just an ordinary star, but an enormous, sizzling ball of gas, mainly composed of hydrogen and helium. It's so large, in fact, that over 1 million Earths could fit inside it. We've also unmasked the sun's energy production process, where it fuses hydrogen atoms to create helium, releasing a staggering amount of energy in the process. This energy lights up our skies and powers life on Earth. Speaking of life, we've delved into the sun's lifespan, learning that it's middle-aged at about 4.5 billion years old. It's got another 5 billion years or so to go before it exhausts its hydrogen fuel. And we can't forget the sun's impact on Earth, from driving our climate and weather patterns to enabling life itself. The sun, our very own star, is indeed a fascinating and powerful force. It's a reminder of just how incredible our universe truly is.
Please do like, share and subscribe to my channel.